So always got a side project going on. This is finishing off the built-in set of units I did in the living room. So it's a fairly typical set of units, which is built-in to the left and the right with chimney rest. So, and went to a bit of extra effort as well, as instead of having cupboards underneath, we've done drawers. And to finish it off, we need to make the drawer fronts, which, as we went for a kind of shaker style, means you need to make shaker drawer fronts, which is a bit of a faff to make compared to just a solid slab. And there's 8 of them to do, so there's a lot to do to make a shaker drawer front. So, first step in making the shaker drawer fronts is to rip down some MDF for the rails and the stiles. The good thing about this is that because the rails and the stiles are going to be about 50mm wide, is we can use a lot of offcuts to save wasting this. I normally like to use the green moisture resistant MDF because it does paint better and machines better with a router than standard MDF, so that's why it's green. So this is only a smaller cut, so we'll probably only get 1, maybe 2 out of this. So first step is we're going to do these demill. So it's a table saw to 50mm, like that. So this is what we're left with. So 50mm width. So next step now is that in order for the panel to sit in this, we now have to cut a slot out the middle of this. So just finishing setting up the router table setup. Just swapped over my dust extractor to go into the router. I actually have a box under the router, it's called the router box, which sucks out the air from down through there as well as out through the fence here. So it has actually helped massively reduce dust from this. So I've also got the GESM rollers installed, which when this runs through, the rollers are on a slight angle, so it puts pressure to keep, you can see this going through here. See, this roller starts to roll. So basically when this hits, this router's running at thousands of RPM, so it stops it. If you didn't have these, this could move up and down a bit. And if you're trying to get a groove perfect all the way through, you need to make sure you've got consistent pressure. So this stops it, and also because it's an angle, it means it keeps it into the fence so it can't come out, and it catches this roll as well. They're not cheap, but it's a useful investment. And there we go. Now I've got the groove running all the way through, which is where the panel will go in. You might have just noticed me there, so I ran it through once. I then flipped it over to run it through on the other side. Now the reason to do that is, so when I set this has always been set to be in the middle of the panel, and I tested it and got it in the middle. It can obviously vary by a fraction of a millimetre, possibly. So by running it through twice, it makes sure it is absolutely dead centre, so it doesn't matter when I come to assemble this which way around I've got. I know that groove will always be absolutely bang on in the middle. So I've now got to do that about another 50 times for each piece before we go on to thinking about assembling it. So this is the rough shape that will be. So they're quite wide and relatively shallow, so it'll be about that. So, and then there's a panel that gets inset into it. So this panel, hence why there's a groove in it, this panel then slots into that. So what I've done so far is I've ran the main groove into them, but the next step is got to make a tenon out of this bit so that it locks into here, which I've got a test piece. So you can basically, if you see here, I basically, so you can see this is the main groove here, and then I also have to rebate the end of it on both sides so that that slots into there like that. So you can see that that basically needs to take a groove off the top and the bottom bit. Now that again is not as easy as you think it would be. Doing these grooves is very quick, but to do these end bits we have to use a special jig, which I'll take you over to now and show you that on the router table. To do this end bit, which you have to run like that, as you can imagine, is not easy to do. Nor is it very safe to do that, and also you also need to make sure that is on a perfect right angle, else that will not fit at a nice right angle. So we've got a jig for that. Well, it's a sled, so it's quite a big contraption just to cut this end piece, but here it is. So all of this contraption, that, well, it looks quite large, and it is quite large, its main purpose is to hold this absolutely perfectly right angle. So we can lock this in. So that's all locked in. So this now, because if you imagine when you're running this across, this is running at ridiculous speed. That wants to obviously spin and flip this out, so this is why everything is locked in. So there are a couple of different sleds that you can get. One locks into the mitre bar slot here, so that keeps it held secure, but if you're using that, it means your fence has to be absolutely parallel to this track in order to do that right angle cut. So the sled that I've got, the Woodpecker sled, does away with that system, doesn't lock into that, and instead it rides this bar along the fence. So this is always going to be at a right angle to the fence because it's right along the fence. Just needs to mean you need to make sure that you're holding it, this is why you've got these handles on, you're holding it nice and tight as you run it to make sure you pressure into that. And then you run it through, and that's how it does the slot, that right angle. I don't actually have a proper tongue and groove rabbit set. Often you can buy a set which has two blades so that you can do both those cuts, both the sides at once. What I actually have to do at the minute is do one side, undo it, and then obviously flip it around and over to do the other side. So, but this bit, this is the test piece, so I'm happy that this is set up now. It's a bit of fine tuning to get the fence right, the height of the bit right, but that's all ready to go now. So, and then the other element, which we'll show you next time, is if you cut. So typically with a shaker, the panel, as you can imagine, sits in the middle of here, so that you get that rebate effect on both sides. So if you open a door, you can see the rebate. With it being a drawer front, because this front has to screw onto the drawer, you don't want that shallow void, so you actually want a solid non-shaker on the back of it. So what that means is, then have to do another step. So here's a rough cut to size of the actual panel itself. So obviously it will sit something like that. Now, as you can see from this thickness of this panel is actually oversized because I want that solid back. So what it means is that I need to router out the edge of this so that it will then sit flush. So effectively it will be like that and sit inside it. So we're over at the mitre saw set up where I'm going to cut these pieces to length. So I've actually recently got around to installing this properly, and you can see I've routed out some of the mitre bars, and this is all slotted in, nicely set up now. This is the Woodpecker Stealth SOP system. So what this allows me to do is, and it's got a ruler on here, and this, if you actually look into the ruler here, the measurement actually starts at about 265 millimeters or something like that, which basically means I've calibrated this so that it's zeroed to the mitre saw. So if I was to cut a piece here, it would come out at exactly, and that needs to be. Obviously, if you start this ruler at 0, you're missing out this whole piece. So that's all being calibrated. And I've set up these stops which flip out quite nicely. So it's a repeatable stop. So this is the one, the short one. This is actually the 298 that I cut before. So this is set up to be repeatable. So to keep on chopping, this is probably one of the offcuts I have. As you can see there, that goes exactly to that size. So that's for repeatable cuts, and then I've got one already set up for the longer rail on the cabinets that we're doing. The right hand side and left hand side of the chimney breasts are slightly different sizes. So this is for the setup for the right hand side, and then this is the one on the left hand side as well for the slightly longer one. So we've already cut the stiles. The stiles is the vertical piece on a shaker, door or drawer. So they're already cut, already grooved as I said before, so they are now pretty much done. The next piece to do is the stile bit that goes horizontally. As I mentioned, we need to do that cut on the ends of it. So now we need to work out actually what width are we going to cut this, which is a very crucial measurement. So if we look at our diagram here, so this represents one of the units in the living room. So in here we've got 4 different drawers, and the overall width of the unit is 1442 millimeters, and it's 600 millimeters high. So in terms of how we've worked out what the individual, so this is the stile here, and that's the rail here for one of them. So in terms of how we've worked out the size of this, we need to allow for some gaps between the sides and the top. So we've allowed a 2mm gap to the left, 2mm in the middle, and 2mm on the right. And then for the vertical, we're going to allow a gap of 2mm at the top and 2mm in the bottom, in the middle. Sorry, the bottom doesn't need a gap. So what that means in terms of how I worked out the stile, this piece here, is so basically we just took 4 off 600 and divided that by 2, which means each of these pieces is 298 millimeters. So we've already done that. Then the next step is, as I said, working out the rails, and similarly we took 6mm gaps of the 1442, and then that gives a measurement 718 millimeters. So that is the width that we need for this rail piece here. Now, that is the correct measurement, or is it? Do you think it is?
No.
Correct, it's not the right measurement. Now, the reason that's not the right measurement is because, so this is what we have to write out in the end, and as you can see if I do a side-on view of that, we've got that tenon which slots into this joint here. So while from the front of this it looks like 718 millimeters, we have to allow, when we cut it initially, extra space so we can channel it out. So and on the test pieces, this size of this tenon here is actually 8.5 millimeters. So what that actually means is we take 718 and we add 7.5 twice, which gives us new measurements that we need to cut the stile to of 733 millimeters. So what that basically means is we cut this to 733 millimeters, and then we'll then take it over the router now, do our grooves on the end, and that's what will then reduce this overall width to 718. So as mentioned earlier, we're now going to feed this into our sled. Make sure that's all tight and square, and then, as I also mentioned before, I don't have a proper router bit, so I have to reverse this. So I actually have to do 4 passes on the router. So we've now got our rail, which is grooved on each end. So that tenon will now go in here. So this now nicely slots into here. And as if on repeater, there's another one I did earlier. So there we go.